Welcome back, ladies and gentlemen. So, today we're going to be beginning our triangles unit, which is actually a fairly fun unit. It has to focus entirely on triangles. Okay, so we're going to go over the basics of what triangles are, properties that exist within them. It's a lot of vocab. The good news is it's a lot of vocab that you've seen before, so it should be nothing new. But here we go. Okay. A triangle is a figure formed by three segments joining three non-collinear points. It's a little tiny minor thing, but it is important. These 3 points cannot be on a line, because if they were on a line, you couldn't form a triangle. Okay, you must have a little bump up. Okay. Each of the three points joining the sides of the triangle is a vertex. Okay, so vertex, vertex, vertex. Every triangle has 3 of those. If you want the plural of that, we call it vertices. Okay, that's the plural. So if you're talking about more than one. And a triangle, 2 sides sharing a common vertex are called adjacent sides. All right, so if they're right next to each other, think adjacent like you're standing next to a neighbor. Names of a triangle. There are 2 different ways to name a triangle, and both are important. By size, you have 3 different ways. You have equilateral, is when you have 3 congruent sides. Okay, so you're looking at 1 side, 2 side, and 3 sides. That's going to be your equilateral. Okay. Now, our next one, equilateral, is pretty simple. It's because of equal, equilateral, equal sides. You got it. Now, isosceles, this is an interesting one. An isosceles is at least 2 congruent sides. Okay. Now, the thing about this is, by definition, an equilateral triangle is also isosceles. Okay, because it has at least 2 congruent sides. But is every isosceles triangle equilateral? No. Okay, it's like one of those weird things of every square is a rectangle, but not every rectangle is a square. So isosceles, for the sake of this class, think of it as if you have 2 sides, bam, you've got it. Okay. And finally, no congruent sides is scalene. Okay, and it's basically just when you have 3 different sides, like a 3, 4, 5, you get the idea. Now, these 3 are classifying by sides. Okay. We may also classify a triangle by its angles. If you have 3 acute angles, which, quick recap, acute is less than 90. So if all 3 of these angles are less than 90, you have an acute triangle. Okay. If all 3 angles, sorry, I wanted to box that off. If all 3 angles are the same, that's called equiangular. Now, what do the 3 angles of a triangle add up to? 180 degrees. So if you divide that by 3, okay, you're going to get 60 degrees. So this is only for an equilateral, okay? Equiangular. Equiangular, all 3 of these angles are 60. And what I do is I put those little half semicircles in there to show you that, okay? Sorry, it's kind of hard to see that for some reason today. Cool. A right triangle. That means that this angle, the one that's a corner, that's your 90-degree angle. Hopefully you guys are comfortable with the right being 90. That also means the other 2 angles must add up to 90 as well. Okay. And lastly, obtuse. Okay. One obtuse angle. Here's a quick question for you guys. Maybe you can think about this. Is it possible to have 2 obtuse angles in a triangle? Well, okay, think about it. If we know the 3 angles have to add up to 180, and one of them's over 90, is it possible to have another one that's over 90? Hopefully you're thinking to yourself, that doesn't make sense, and that's good, because if you have 2 obtuse angles, it would not be a triangle. It would be a 4-sided, 5-sided, so on. Okay? Very nice. All right, this is highly important. This is where we're going next. Okay? In a right triangle, the sides that form the right angle are the legs of the triangle. So first off, right triangle. Bam. All right, we've got ourselves a right angle. It's 90 degrees. Now, the 2 sides next or adjacent to the right angle are called your legs. Leg, leg. All right? That's some very important vocab. We will be using it a lot as the year goes on, okay? Especially because the next chapter after triangles is right triangles. The longest side is called the hypotenuse. Okay? The hypotenuse is always opposite of my right angle, always across from. Okay? So you will hear me drop these words a lot in class. We'll talk about it a lot. You'll see it in your tests, your quizzes, so on and so forth. Okay? Cool. All right. On the back, we're looking at isosceles triangle. And again, isosceles is two sides. So here is, I'm going to roughly draw. And by the way, hopefully you guys are cool with this. When I do these tick marks, that means this side is the same length as that side. An isosceles triangle can have three congruent sides, in which case it's equilateral. We just talked about that. When an isosceles triangle has only two congruent sides, then those two sides are the legs. So we call this the leg and this the leg. Very similar to the right triangle terminology. The third side, however, we don't call it the hypotenuse. Hypotenuse is only for the right triangles. We call this the base. Okay? And like, I always like to think of, when I look at an isosceles triangle, like, like a volcano, like, oh, it's exploding. No, run for your life. But like, that's the base of your mountain. Those legs are the sides of your mountain. Okay, and they're the same length. I don't know. I just like to draw pictures, I'll be honest. Okay. So, we're going to classify each triangle, be as specific as possible. Whenever I ask you guys to classify a triangle, you're going to give me a word for the sides and a word for the angles. Okay? So looking here at part A, doesn't matter which one you do first, but I'm going to do sides. I've got one side the same, two sides the same. So two sides the same, I flip my page over, okay? At least two congruent sides, that's isosceles. All right, we're going to use our notes to our advantage. So, for number one, part A, we have an isosceles. Cool. Now I'm looking at my angles. 45 degrees, 45 degrees, 90 degrees. The moment you have one right angle, it's automatically an isosceles right. You can write the word out, triangle out. I'm very lazy, so I want to use the symbols for it. Isosceles right triangle. We're all good. Okay. Awesome. So for part B, what I've got here is I've got myself, okay, so if you take a look at the sides here, no sides are the same, no tick marks. So that's scalene. And now I look at my angle, I have a 130 degree angle, that's greater than 90, so therefore that's obtuse. So a scalene obtuse triangle. Okay, very cool. All right, this is probably one of, if not the most important things you're going to learn for this entire chapter / year. I don't really know if I can stress that enough. I don't know if I could really emphasize enough how important this is. You really need to know this, okay? Now, the good news is you've been doing this for so long now that I'm sure you're fine with it, but please make sure you make a note of this. Triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. The measure of angle A, M angle A, plus the measure of angle B, plus the measure of angle C equals 180 degrees. All right? Please make sure you know this one. Like, honestly, there's like 10 ideas that by the end of this year, when you walk out of my class, I hope that you have in your back pocket for geometry. This is one of them, okay? There's also exterior angle theorem. The measure of an exterior angle of a triangle, exterior means outside, is equal to the sum of the measures of the two non-adjacent interior angles. So, the angles not next to 1, okay? So A and B. If I add A and B together, the measure of angle A plus measure of angle B, it'll equal the outside angle, okay? And this right down here as well, corollary to the triangle sum theorem. The acute angles of a right triangle are complementary. Here's a throwback. What does complementary mean? Add up to 90 degrees. Okay. You don't need to necessarily know this. It's more of it's just kind of a shortcut. If you know one angle is 90, the other two have to have 90 as well. That's all. So to end right here for the notes anyway, I'm going to end with two exterior angles theorem. I'm telling you guys right now, those of you that are listening on this video, on your next test, you will have one of these problems for sure. Okay. The two inside angles, x plus 50 equals 2 parentheses x plus 4 equals the outside. So, well, we just got to solve it. Distribute the 2. x plus 50 equals 2x plus 8. Okay, I'm going to subtract the x over. 50 equals x plus 8, and I'm going to subtract 8 over. X equals 42. Okay, sorry, it's kind of a little glare there. And if you guys would like, all right, to find the measure of the exterior angle, so now it's asking us to find the measure of the exterior angle. Guys, exterior means outside. I'm taking 42 and I'm plugging it in. So 2 parentheses 42 plus 4. 2 times 46, okay? 2 times 46 gives me 92 degrees. I'm really going to emphasize too. Remember degrees for angles. Okay? Remember degrees for angles. So, same idea over here. I'm going to do the two inside add together. So we're looking at x plus 70 equals 3x plus 10. All right. No distributing here. Get all the x's on one side. 70 equals 2x plus 10. Subtract 10 over. 60 equals 2x. Divide by 2. X equals 30. So really close. Take that 30, plug it back in. 3 times 30 plus 10. You're looking at 3 times 30 is 90 plus 10, 100 degrees. Okay. So there's our intro to triangles. We covered a lot of good stuff there. Really though, please make sure you guys remember the triangle sum theorem. All right. So like you're going to hear me ask that a lot in class. We're in good shape. So as always, keep up the good work and good luck.